Good day, class. Hope you're doing well today. We're going to look at some proofs again in this lesson. However, instead of using truth tables, we're going to be using algebra as well as some theorems specific to Boolean expressions. So I've listed the 10 main theorems here. At the bottom, there are 2 additional laws, but we will focus on those in a later lesson. So the first 2 here involving multiplication and addition of 0. The next 2 involving multiplication and addition of 1. Theorems 5 and 6 involve multiplying a by itself and adding a to itself. In rules 7 and 8, we are multiplying a by its conjugate or by its inverse, so a times a naught, a plus a naught. And then rule 9 is for a double inversion. So if you take a naught and invert that, you get back to a. So I think if you give it some thought, you'll find that these first 9 are quite logical, particularly if you think about a truth table when you're looking at the theorems. This last one is less obvious. It's called the Absorption Theorem. It says a plus a naught b is a plus b. That's just one form of the Absorption Theorem. And it has multiple forms, and I will illustrate how you use those within our proofs today. Okay, so again, we'll wait for these ones. Today we're going to focus on these rules. Okay, so this is the kind of thing we're going to do. So we have our expression here. We want to prove that the left side is always equal to 0, but we're not going to construct a truth table to do this. We're going to perform algebra on the left-hand side. So I'm going to write here the left side equals, okay, so now this is multiplication implied. So I can expand this left side out using multiplication. So AB can be multiplied by A naught. And then to that, I will add AB multiplied by B naught. And I like to write it in alphabetical order. So the first term, AB times A naught, I would write like this, A naught, B. Plus, okay, so the next term is AB multiplied by B naught. And that would look like this. Okay, so that's opening up the brackets. And now, is there a theorem that we can use here? We have A times A naught here and B times B naught here. And if you take a look at the theorems, that is rule 7. Something multiplied by its inverse is always 0. So right here, I have 0 multiplied by b, so 0 times b. Plus, here I have a multiplied by 0. Okay, so we can put these little multiplication signs in if you like. And I'll just write down here that what I used in order to make a 0 here and a 0 here was rule number 7 on our list of theorems. And then from there, it's fairly straightforward. 0 times b is 0. A times 0 is 0. And that's true in any number system. But, you know, it's also rule 1 in our table. Okay, so if you wanted to, you could reference rule 1 here. And now that gives us a sum of 0 as required. Okay, let's try the second example here. So the first thing I'm going to do is open up this bracket. Again, using multiplication. We're working with the left side because it's more complicated than the right side. So left side, so it's A times AB plus A times B. Okay, now is there anything striking about those terms, either of those terms? And I'd like to suggest that this should stand out to you, a times a, within that first term. If you look at your list, we have a times a in Rule 5, and it's just equal to a. So that means this a times a here can just be made a. So that term becomes ab. Okay, so the rule that we used to turn a times a into a was Rule 5. And now what? We have AB plus AB. So we're adding two things that are identical. Where does that happen? That's Rule 6. If A plus A is A, then AB plus AB is AB. So this is just equal to AB. And again, that was rule number 6. And we're happy now because we have a match to the right-hand side expression. Okay, let's have a look at the next one. We have ABC plus A times BC all inverted. There is no bracket here to open up like there was in problem 1 and in problem 2. So what we're actually going to do on the left-hand side is the opposite of that. It's called common factoring. So in both of these terms, A is common. So A is removed as common from the two terms. What would be left here? BC. Then the plus sign. And what would be left here? BC all inverted. So that's removing the A as common from the two terms. You'll note that if you were going to open up the bracket using multiplication, you should get this back. Now, why did we do that common factoring? Why was that so important? Well, now take a look inside the bracket. We have BC added to its inverse. Which theorem will be important? A added to its inverse is 1. So BC added to BC all inverted is also 1. So this is Rule 8. So we now have A multiplied by 1. And again, I used Rule 8 there. Finally, then we have A times 1. And again, in any algebra, that's equal to 1. That's equal to A. But if you wanted also to refer to your list, it's here. A times 1 is A. So that's Rule 3. A times 1 is A. So that is Rule 3. Okay, number 4. Let's go ahead and look at that left side. We do have a bracket, so we might like to open this up using our multiplication. And there will be 5 letters in each term. And I'm going to write them in kind of an alphabetical order. So here it would be A, B, B naught, C. And then the plus sign. And now we take ABC and multiply it by AC naught. And again, in alphabetical order, that would be A, B, C, C naught. It's just easier to use alphabetical order because then the theorems are easier to spot. The most relevant theorems are most easily spotted. Okay, now here, a couple of possibilities are apparent. So one thing that's apparent is the fact that we have A times A here and also here, and that can be reduced to just A. But also we have B times B naught here and C times C naught. And each of those is just a 0. Okay, so, you could just do one thing first if you want. I can change that to an A. Same thing here, I can change this just to an A. But that's kind of an optional step, so that's using Rule 5. A times A is A. That's rather an optional step since we have 0 now in each of these terms, because this is now A times 0 times C, and over here, A times B times 0. B times B naught is 0. C times C naught is 0. Again, that's according to Rule 7. And so now this whole term is 0, and so is this whole term, because when you multiply AC by 0, of course you'll get 0. Here, multiplying AB by 0 is 0. If you wanted to cite a rule here, just for your reference, it would be this one. When you're multiplying by 0, you get 0. So that would be Rule 1, giving us a sum of 0 as required. Okay, so let's continue. I'm going to do 4 more with you here. So let's take a look. This is problem 5, left side. So we've got the bracket. Let's open it up. So we're going to get A times A plus A times B. Now, which theorem is most important? Take a look. Hopefully, you're looking at number 5. A times A is A. That allows us to change the first term to plain old A. Okay, so that's Rule 5. But what do we need to do next? The next step is the crucial one. You can't actually apply a theorem at this point in time. It looks a little bit like number 10, but the bar is missing here, so it's certainly not number 10. What you need to do now is common factor the A from both of these terms. When that A is taken out of the first term, you have to remember to leave behind a 1. So a 1 is left behind here, then the plus sign. And when A is taken out of these terms, using division, a B is left. Okay, so what you're really doing is A divided by A is 1. AB divided by A is B. Just like this, it has to look. That's the common factoring step. Check it. If you were going to open up the bracket, you should get back that previous line. Okay, so that's common factoring. Now, why was that so important? Because now inside the bracket, we have 1 plus B. What is 1 plus B equal to? 1 plus B is 1. 1 added to anything is always 1. So according to Rule 4, that bracket becomes a 1. That's Rule 4. Now we have A times 1, and again, that's going to be A. That's in any algebra. However, you can take a look here as well. A times 1 is A. That's Rule 3 if you want to cite a rule. And the key is that it matches the right side. Okay, let's look at number 6. What should we do in the left side? I should point out that the solutions are not unique. So sometimes there are multiple ways of getting to the expression on the right side. And this is one of those cases. You could proceed in different ways here with number 6. So some of you might start by common factoring A from these first two terms. And some of you might not. Some of you might start by moving this term close to this one and then using Rule 10 right away. So I'll just maybe show you one of those options. I'm going to take the A out as common from the first two terms. So the a comes out as common from the first two terms. That will make 1 plus b in the bracket. This last term is still here, added at the end. So the a can be common factored from the first two terms just like this. After the plus sign, we still have this third term. Okay, the reason I did that, of course, is here. Now in the bracket, we have 1 plus b, which we know is equal to 1. Okay, and that 1 plus b equals 1 is right here. 1 plus b is 1. Number 4. So now we have a times 1, or a plus a not b. Okay, so a times 1 is certainly a. If you wanted, you could refer to number 3 for that one. A times 1 is a. Okay, so we could say that that's number 3. And now look what we're left with, a plus a not b. And this is definitely rule 10. A plus a not b is a plus b. This is called the Absorption Theorem, and it's number 10. Okay, and on a test, you do not have to put in any of these references for me. I just need to see the algebraic steps. So if you don't want to put in the references here, I'm totally fine with that. Okay, we're going to do the next two together, and then I'm going to get you guys to try some on your own. So left side of number 7. Now this is quite different than what we've looked at so far. It's the multiplication of two binomials. So you might know how to do this. We're going to get 4 terms when we do the multiplication here. First, outside, inside, last, like that. So first it's a naught times a, or a times a naught. Then a plus sign. Then a naught times b naught. Then on the inside here, it's b times a, or a times b. And then the last term is b times b naught. Okay, so we get 4 terms when we multiply two binomials. And you might remember that little mnemonic device using the word FOIL. First, outside, inside, last. Like that. Now look at the right side and look at what we have here. Which theorem is to be used? What do you guys think? Number 7, right here. Number 7, number 7. And when we use rule 7, we do this. We say a times a naught is 0. So that means this term is 0. The first one there. And this term is 0. The last one here, b multiplied by b naught, is also 0. So that's rule 7. And so what are we left with? Just these 2 terms, which is the right side. We can certainly change the order of these 2 added terms. Addition works that way. Okay, so we end up with the right side now as required. Okay, last example. 2 binomials again. So let's do our multiplication. On the left side, we have AB times AC plus AB times BC plus, on the inside here, BC times AC and finally, the last term, BC times BC. Like that. Now take a look inside each term. You can see we have some repeated letters. So which theorem is most important? That would be number 5. So number 5 is going to let me change this term to ABC and this one to ABC and this one to ABC, and the last one to BC. So that's rule 5. That was really important. Now maybe this is jumping out at you next. So this next term is kind of optional, but I'm going to throw it in there. What do you think ABC plus ABC plus ABC is equal to? That's just one of those ABCs. So all 3 of these. And then at the end, we'll still have plus BC. Which rule did I use there? ABC plus ABC plus ABC is ABC. Which rule is that? That's actually this one, something added to itself. Okay, A plus A is A. So that means A plus A plus A is also A. Okay, so these 3 are here. This last one is here. Okay, now the key. How do we continue? So, I should say here I used rule 6 to change this to this. And now the key is common factor BC from the terms. In doing so, from this term will be left A. Then we'll have the plus sign, and from this term will be left a 1. So that's the major common factoring step that's required. Check it. If you were going to open up the bracket using multiplication, you'd get this line back. The reason that's so important is it gives us that almighty 1 inside the bracket here. What is A plus 1 equal to? A plus 1 is 1. Number 4. And now finish up. BC multiplied by 1, of course, is BC. And that's true in any algebra, but also in Boolean algebra. So where's that? Right here. A times 1 is A. So BC times 1 is BC. Okay, so if you want, you can refer there to rule 3. All right, so this was a nice juicy problem, many steps. First, the proper expansion of the multiplication of 2 binomials, then reducing, right? All of these repeated letters, here, then adding 3 terms that were the same, and then this key step here. Again, why is it so important? Because it leaves us a 1 in the bracket so that we can use theorem 4. Okay, so I would love for you guys to practice this. I have posted 8 problems for you in Blackboard, so please try those, and I've also posted my solutions to those 8 problems just in case you get stuck on them. Okay? All right, thanks so much and have a great day.